Mathilda, I'm ready. Teach me the power. Is it a laser beam?
Not exactly a ta, but it is a superpower for circles.
Disappointed. Method acting ruined.
It relates the lengths of segments created by lines crossing a circle.
All right, show me this geometry magic.
Let's explore what happens when two chords intersect inside a circle. Suppose we have two chords, AB and CD, which meet at point P.
So the point P splits each chord into two separate segments?
Exactly, and there's a beautiful constant relationship here. The product of the segments of one chord equals the product of the segments of the other. To prove this, let's connect A to C and B to D to form two triangles. The angles at P are vertically opposite, so they are equal. Angles A and D are also equal because they both subtend the same arc, BC. Thus, triangles APC and DPB are similar by AA similarity. Their corresponding side ratios lead us directly to our product formula.
That makes sense. Similarity is a powerful tool for proving these circle properties.
Let's apply the theorem to an example. We have two chords intersecting at point X. We know three segment lengths, 3, 4, and 2. Our goal is to find the missing length, X.
The theorem states that the product of segments on each chord is equal. Plugging in our values, 3 times 4 for the green chord, and 2 times x for the orange.
That simplifies to 12 equals 2x.
Divide both sides by 2, and we find that x equals 6.
Perfect, but what if P escapes? Point P is now outside the circle. These lines are called secants.
They look like antennae. Does our rule still work?
The formula is still PA times PB equals PC times PD, but there's a trap. Stop! Don't just look at the segments inside the circle. PA is the distance to the near point, red. PB is the distance to the far point, the whole length, green. The same applies to the other side, PC, external, and PD, whole. The trap is using the internal parts AB or CD. Never do that.
Got it. External times whole. It's consistent.
Example 2. Secant segments. PA equals 4, AB equals 5, PC equals 3. Find x.
Easy. Just multiply the segments. 4 times 5 equals 3 times x.
Wait, that's the trap. You can't just multiply the internal parts. The rule is external times whole, not part times part. For the top secant, the external part is 4, and the whole length is 4 plus 5 equals 9.
Oh, I see. So 4 times 9 is 36.
Exactly. For the bottom one, it's 3 times the whole length, 3 plus x.
Solving for x gives 9. That makes much more sense.
One last transformation. If I push it until A and B merge into T,
It's a tangent.
since A equals B equals T, PA times PB becomes PT times PT. This is the Tangent-Secant theorem. Last one, Atta. A tangent and a secant through the center. Find the radius.
The power of a point says pt squared equals pa times the whole length pb. Since it goes through the center, pb is the external part 4 plus the diameter 2r.
Spot on. Now solve the linear equation.
The radius is 6. That was actually quite satisfying.
Remember, it's always part times part or external times whole.
The power of a point. Thanks for watching Mathilda Academy.